Good morning, all of you. So, in today's class, we will learn isothermal process. What we are going to learn in today's class? Isothermal process. In the last class, we have finished isochoric process. Yes, isochoric process means what? The process where the changes takes place at constant volume. And here we are learning in this class isothermal process. So, in this process, what is the case then? Temperature will remain constant. What will remain constant? Temperature. Yes or not? So let's see what is this isothermal process. So in this process, system undergoes physical change at constant temperature. At constant temperature. Then that is called isothermal process. So what are the conditions for this isothermal process that are important? Essential conditions. Let's see what are the essential conditions for this isothermal process. So listen carefully. The number one essential condition. The walls of the container must be perfectly conducting. Okay, what is that? The walls of container must be perfectly conducting. I will show you one diagram. Must be perfectly conducting to allow free exchange of heat between the gas and its surrounding. Between gas and its surrounding. So let's see one diagram for this so that you will understand. I am taking a container here. Okay, let's see, take a red color container so that you'll understand perfectly. This is a container and these are the walls. In this gas is filled. Okay, what is here? This is a gas, we can say, and these are the walls, and this is surrounding whatever it is around it. So I am keeping one arrow here like this so that you will understand how the heat exchange is taking place. If you want above and down also, not an issue. Surroundings here also, I am just showing two side only. So if you want above also, not an issue. Okay, so this is surrounding I am taking. So there is heat exchange takes place, right? How? Heat exchange, heat exchanges between gas and surrounding. Here you can see, right? This is what the first condition, and that's what this wall should be perfectly conducting. Understand, of the container is, you can see here. Understand the first point? Yes. If you want, you can keep piston also here. If you want, you can keep a piston like this. And you can shade also, not an issue. So this I am shading with white color. This is what piston. We'll take red only. Okay. Can you see this? This is what piston. Understand? So like this, the first condition is. So let's move ahead and see what is the second condition of this isothermal process. So second condition, process of compression or expansion. Process of compression or expansion should be so slow, should be so slow to provide time for the exchange of heat. To provide time for exchange of heat. So what it means? Listen carefully. The second essential condition. So process of compression or expansion should be so slow means this piston is there. So either it is coming down means compression. This piston is going up means expansion. So this process should be very slow. It should not be fast. Why? So that heat exchange can take place between the surrounding and gas. Okay, surrounding and gas. Understand? Okay, so this is what the essential condition. But see here, understood no this point? Compression and expansion means this, you take one injection, that syringe, you know, है ना? वो पिचकारी खेलते हो ना आप लोग, पिचकारी. So slowly you push and slowly you just pull out. So like that, you assume that there is a gas in that, whatever that pichkari or whatever it is, and you are pushing and pulling outside that piston. So there is expansion and compression of the gas which is filled in between, and due to that exchange of heat will get some time. It should be so slow. That pulling and pushing of that piston should be very slow so that heat exchange can take place, or it will get some sufficient time for heat exchange. Understand? Okay. So see, these two conditions. So these two conditions not fully realized or not possible practically, not possible perfectly Therefore, no process is perfectly isothermal. Therefore, no process is perfectly isothermal. Perfectly isothermal. Understand? Clear? No process is perfectly isothermal. No process is perfectly isothermal. Understand? If they are asking you why the perfectly isothermal process is not possible, what you will say? You will say that these two conditions are very difficult to attain practically. Okay, so that's why no process is perfectly isothermal. Okay, so let's move ahead. Now, equation of state for this process is what? Which process? Isothermal process. And what is its equation of state? So let's see what is the equation of state. Now, what is constant in this? Temperature is constant. If temperature is constant, you know, if temperature is constant, what will be the case? Pressure is inverse proportional to volume, hai na? You know this or not? So in this, what we are getting? T is constant, P and V changes. Yes or not? Temperature is constant, pressure and volume changes. Next point, in this process, which law is going to obey? Boyle's law, hai na? Boyle's law is obeyed. So what is Boyle's law? Pressure is inversely proportional to volume, and therefore PV is equal to constant. है ना? PV is equal to constant, and therefore equation of state what will be? P1 V1 is equal to P2 V2 for isothermal process. This is what your equation of state in the isothermal process, right? Next one, what are the examples of this isothermal process? So see here, examples of isothermal process. Write down slowly, slowly we will learn, but don't leave any doubt behind. Okay, slowly. If you have doubt, ask me, call me. Okay, need notes you write, need slowly, no need to be hurry. Okay, examples of isothermal process are what? Let's see. Number one example I am giving. See now, when there is a state change, for example, 0 degrees Celsius ice to 0 degrees Celsius water, boiling of water, 100 degrees Celsius water to 100 degrees Celsius steam, temperature remains constant, isn't it, right? Yes or not? So shall I write like this? Melting of ice, that is at 0 degrees Celsius. Which process? Isothermal process. Second one, boiling of water. Boiling of water. At which temperature? At 100 degree Celsius. Understand? These are the some examples which are very easy of this process. Which process? Isothermal process. Understand? There is no doubt. Why? Because here temperature is remaining constant. Already I told. And melting process is taking place. 0 degree Celsius ice is getting converted into 0 degree Celsius of water. And 100 degree Celsius water, when it is boiling, it is getting converted into 100 degree Celsius steam. Understand? That is what your isothermal process. Right. Next. Now, indicator diagram for this process. Next part is what? Indicator diagram. Now, who will tell me what type of indicator diagram will come, Ray? Indicator diagram will come as like a Boyle's law, hai na? Yes, indicator diagram means what? PV curve. So if in this process already we have learned what type of equation you got, PV is equal to constant, hai na? So you will get the curve which is indicates the Boyle's law. Yes or not? Which indicates Boyle's law. So let's see how it will be. So this side I am taking pressure and this side I am taking volume. And if I will plot a graph, what type of graph I am getting? Like this graph you are getting. Yes or not? Right? Like this graph we will get. This is for one temperature, hai na? This is for one temperature. So if you want another temperature, you will get like this graph. This is for second temperature. And this one for third temperature. Yes. So this one is for what? Which temperature? T1. This one is for T2. This one is for T3. This one is for T3. So if I will plot slope of this, if I will take slope of this graph with these dotted lines, we can see these dotted lines are nothing but the slope of this line which I have taken, and let us assume that you are having this angle as a theta. This is what? Theta. And here which one is greater here? This side T3 is greater than T2 and then T1. T1 is less temperature. And how is the graph? Rectangular hyperbola. How is this graph? This curve line is what? Rectangular hyperbola. Kasla bola? Rectangular hyperbola. Curve is what type of curve you will get? This rectangular hyperbola. Can you see this? And now I want to find the slope. What I want to find? Slope. So now let's see what we are getting. The slope of this curve. Slope is nothing but what? Tan theta, isn't it? What is slope is nothing but what? Tan theta, and this tan theta is equal to what, Ray? Tell me. Tan theta is what? This change in pressure by opposite by adjacent, है ना? So change in pressure by change in volume. This is what? Change in pressure. This one is what? Change in volume. So this is equal to minus P by V. Minus P by V. Why? Because pressure changes from maximum to minimum. Isn't it? Maximum to minimum. So therefore minimum minus maximum. That's why we are getting minus sign. Okay. So let's move ahead. Next point here. If now what happen? If volume increases, or first let me write this line, area between isotherm curve and volume axis, isotherm and volume axis gives work done. Obviously already I told you work done under the graph of PV will give you work done. This is already we know, area under the PV graph you will get work done. Okay, so note down this all and let's move ahead. Now next point is what? See, if now volume increases, if volume increases, what happens? Delta W is positive or negative? If volume increases, delta W is equal to positive. Already I know, or we know, the delta W is what? P into dV, है ना? So volume increases means final volume is more than the initial volume. So definitely work done is what? Positive. So area under curve is what? Positive area under the curve you take, है ना? Positive area under the curve if you want from the curve. Clear? Next, and if volume decreases, yes, now you can write blindly, है ना? How you can write blindly? Can you? Negative area under the curve. So whatever the area you are getting, you just decide volume is increasing or not, and from that you just substitute the sign for work done. Clear? Okay. So let's move ahead again. Next one, in this specific heat is what? Specific heat in this process. Which process? Isothermal process. Specific heat. Now you know specific heat formula is what? S is equal to Q by M delta T. है ना? Q by M delta T. In isothermal process, delta T is equal to what? Bolo, in isothermal process delta T is equal to 0. Delta T is equal to 0. Therefore, S is equal to Q by M into 0, and that is equal to Q by 0, and therefore S is equal to infinity. Anything by 0 you are getting what? Infinity, and therefore specific heat in isothermal process is 0. Yes or not? Understood this? This is what specific heat in case of isothermal process. right? Next one, next point, isothermal elasticity. What is this isothermal elasticity? Isothermal elasticity. This is denoted by E of theta. It is same like a bulk modulus. You know, bulk modulus, same like that, but in isothermal process, we are calling it as a isothermal elasticity. And what you are getting this, let's see. So here in this process, we know PV is equal to constant, है ना? Boyle's law is obeyed, no? So PV is equal to constant. As PV is equal to constant, so can I write like this? This I am differentiating, differentiating first I am getting P into dV plus P into dP is equal to 0, and therefore you are getting P into dV is equal to minus P into dP, and therefore if I want only P, just transfer this that side, so minus P dP divided by dP. Now this dP I am transferring down, so I am getting P is equal to minus P divided by dV by P. So first dP I am keeping here instead of this P. So let me keep this dP upside, and this P I am transferring down. So this dP as it is, and down this dV by Phi, dV by Phi, and that is equal to stress by strain. That is equal to stress by strain. Stress means what? Force per unit area, and strain means what? Original length by change in length by original length. So here I am getting stress by strain, and that is equal to E theta, and therefore E theta is equal to P in this process. E theta is equal to P in this process, and at normal temperature and pressure at NTP, at normal temperature and pressure, E theta or P is equal to how much? Atmospheric pressure. How much is the value? 1.01 into 10 to the power 5 Newton per meter square. Keep it in mind. This is what your isothermal elasticity. What is this? Isothermal elasticity. And let's see the work done in isothermal process. Right? Next part, that is what? Work done in isothermal process. Right? So see here, how is the work done in this process? Work done in isothermal process. Okay, how to find the work done in this process? Let's see. So first of all, what is changing here? Volume is changing. What is constant? Temperature is constant. Okay, so let's see what we are getting here in this process. How is the work done? So now We know one formula, W is equal to integration of from initial volume to final volume P into dV, है ना? P into dV. So we know from ideal gas equation, from ideal gas equation, if you want you can write below also, not an issue. Okay, instead of writing here you can write here also. So write like this, from ideal gas equation. What is ideal gas equation? PV is equal to nRT. Yes, PV is equal to nRT. Therefore, if I want pressure, what I am getting? nRT by V. And therefore, substitute now in this above equation. What we are getting? W is equal to integration of Vi to Vf, that is initial volume Vf, Vi to final volume Vf, nRT divided by V into dV, right? W is equal to what? nRT by V into dV. Okay, now what is constant here? nRT can I take outside? nRT shall I take outside? So W is equal to nRT, as it is a constant. N is number of mole constant, R is universal gas constant, constant, T is constant. So what is left inside? 1 by V dV from Phi to Pf. So 1 by x integration. Formula you know, integration formula. 1 by x dx integration. क्या होता है? ln of x. What is the formula? ln means log to the base e. Okay, so just at the place of here 1 by v you are having, so you will get ln of phi. So just keep it in mind. So W is equal to, you are getting nRT. Yes, W is equal to nRT ln of phi, and you have to keep upper limit and lower limit. That's it. Very simple. Phi and this is Pf. So at the place of phi you substitute this. So what you are getting? nRT ln of Pf minus ln of Phi. Put upper limit, subtract lower limit. So that is equal to what I am getting? nRT log A minus log B. What you are getting? Log A by B. So therefore Vf by Phi. Yes or not? Since you know this, what? ln of A minus ln of B is equal to ln of A by B log A minus log B is equal to log A by B. So I got this W is equal to what? nRT ln of Pf minus Pi. This is what work done in the isothermal process. Okay, understood. Now this is ln, right? So, but ln is equal to 2.303 log to the base 10. This is ln means log to the base e. Okay, ln is equal to what? Log to the base e. This is what your conversion. So therefore, you are getting now W is equal to 2.303 log to the base 10 Phi of nRT is left, no? So nRT we will first keep, right? है ना? nRT is there, no? So let's substitute here. So 2.303, this nRT log to the base 10, and this is Pf by Pi. Okay, this is what your formula in terms of log to the base 10. Okay, sir, understood. If I want formula in terms of pressure, PV is equal to constant. Yes. Here from Boyle's law, we know what we know from Boyle's law. We know PV is equal to constant, and therefore Phi is equal to PF F. है कि नहीं F? So now F by Phi. So I am transferring this side. So what I am getting, this Pi by Pf is equal to Pi by Pf is equal to Pf by Phi. If we will substitute, therefore we are getting W is equal to 2.303 nRT log to the base 10 inside bracket. At the place of this Pf by Vi, what we can substitute? Pi by Pf. And therefore this is what your work done formula in terms of pressure. So you can give this as equation number 1, this one as equation number 2, and this one is as equation number 3. Okay, right? Clear? Understood? Very simple. This work done. They may ask you for 4 marks also. Keep it in mind. This work done formula is very important. Okay, finished. And next one, that is in isothermal process. What is the first law of thermodynamics? So in isothermal process, delta Q is equal to delta U plus delta W, है ना? Yes, this is what first law. But what is the case here in isothermal process? So here, as delta T is 0, delta T is equal to 0 because T is constant. Therefore, delta U will become 0, and therefore delta Q is equal to delta W in which process? Isothermal process, because there is no change in temperature, so no change in internal energy, and that's why delta Q is equal to delta W. What it means? Tell me. So it means heat supplied is used to do external work, against surrounding materials, to do work against surrounding. Against surrounding. Or we can say, if work is done on the system, then what will happen? Equal amount of heat will liberate, है ना? If work is done on the system, equal amount of heat will liberate. Got it? This is what your isothermal process. Understand? So read carefully. Let's stop here. Enjoy the day.